spanning tree protocol. Okay, so I gave you an idea. This protocol is to avoid the layer 2 loops. It is to avoid the layer 2 loops, or else we call it as bridge loops, bridging loops. Both are one at the same, right? So this protocol, spanning tree protocol, is to avoid the layer 2 loops or else bridging loop, right? Yeah. So spanning tree protocol, it is an open standard where IEEE has given a standard of 802.1d for spanning tree protocol, right? To avoid bridging loops or layer 2 loops caused due to redundancy links. And usually we call it as common spanning tree. Okay, spanning tree protocol can also be called as common spanning tree protocol. Common spanning tree protocol, right? And no redundancy in traffic paths for frames. Okay, this is my switch 1 and I'm having two redundancy links to switch 2. Okay, now this is my DP, this is my DP, this is my root port and this is my blocking port. So this will be the down state and this will be the up. So whatever the frame it received, it has only one link to flow. It has no redundancy path. I told you the BPDUs. These are the messages used by the spanning tree protocol. So if you are considering BPDU, these are all the fields. What is the protocol identifier? What is the version? What is the message type? Flags, you will be having some flags. This is root ID, that is root bridge ID. Okay, this is the root bridge ID, right? This is my root path cost. Root path cost, that is very simple. 1, 2, okay, 1, 2, 3. This is my root bridge, right? Physically, all the three switches are connected. Okay, so now there will be a scope of loop, right? There will be a scope of loop because a packet has received on packet switch number 3. It may go for switch 1 and again it may go for switch 2 and again switch 2 may send it back to switch 3. There may be a scope of loop. So what we have to do, we have to run STP and we have to block one link, right? So what will we do? So this is the root bridge. He will send his BPDU to this bridge, that switch, and he will send his BPDU to this switch also. Now switch 2 is sending the same BPDU, that's saying switch 1 is a root bridge to the switch 3, right? This root bridge, he will send BPDU as think that his MAC address is A, his MAC address is B, and his MAC address is C, right? Protocol and this is the not ready, this is not ready, this is not ready. Root ID, root bridge will send root ID as A. Root path cost as 0 because he himself is a root bridge, so he will never have some cost, right? Bridge ID is who is sending the BPDU. He will keep it as A. Okay. Port ID will be on what port you are sending the BPDU out. That will be the port ID, right? So message age is like time at what the BPDU is generated, and up to what time can it be alive. That is the thing. So yeah, max age in STP, max age will be 20 seconds. Hello time will be 2 seconds. That is, for every 2 seconds, root bridge will be generating the BPDU. And forwarding delay is 15 seconds. We'll discuss this, what is this forwarding delay, in the next slide. Okay. But now, so this is a BPDU sent by root bridge to the switch B and also to the switch C. Here the port ID will be varying, because if the BPDU is sent to switch B, for suppose think my port number is 1 here and port number is 2 here. If it is sending the root BPDU to switch B, port ID will be 1. If it is sending the BPDU to switch 3, port ID will be 2. Okay. So this is the BPDU sent by root bridge to switch B and switch C. Got it? Now what will happen? Now switch B should forward this BPDU to this switch. What will it do? Same. Root bridge ID will be same. A. It means that switch 2 is telling that I am not the root bridge, but switch 1 is a root bridge. Okay. Root bridge ID in the BPDU will be same for all the switches. Root path cost, for suppose it received the BPDU, now it will calculate the cost. Cost will be dependent on the interface. If it is fast Ethernet, it will be some cost. If it is a serial port, if it is a gigabit Ethernet, it will be having some cost. If it is Ethernet, it will be having some cost. Okay, for timing, think that it costs 10. Okay, so it will tell that if you send me the data, or else if you want to reach the root bridge through me, the cost will be 10. Okay, what will be bridge ID? This switch 2 is sending the BPDU to switch C, right? So bridge ID will be B. Okay, all the BPDUs, their root ID will be same. Sender bridge ID will be varying. Sender bridge ID. Bridge ID is in the sense sender bridge ID. Who is sending the BPDU? His ID will be inserted in the bridge ID. Okay, so port ID will be ultimately again, for suppose think that here 3, and these all will be same. Okay, so now you came to know what is the sender bridge ID, where it varies. If this switch sends the BPDU to other switch, but actually this is not the root bridge, then the sender bridge ID and root ID will be varying. Okay, that is a thing. Okay, now when it received here, it received the BPDU from switch 1 and from switch 2 also, right? First thing is it will compare who is the root ID. Okay, root ID is same. Now it will compare the cost. What is the cost sent by switch 1 to me, and what is the cost sent by switch 2 to me? It is sending cost 0, but it is sending cost 10, right? It is sending cost 10. It will carry, it will calculate. I am receiving 0 on this. Okay, and now I will add my cost to it. For suppose think my cost is 5. 0 plus 5. So my total cost is 5. From in order to reach root bridge on this interface, my cost is 5. Right? This bridge it is sending cost 10, and my cost will be 5 here. My total cost will be 5 plus 10. It will be 15. So here, who is having the, which port is having the low cost? 1 and 2 will be the, which port will be the having the lowest cost? 5 is having. So ultimately these will become the root, right? Okay. Now, so this will be the DP. I told you already. Every port on the root bridge is DP, designated port, because ultimately it has to only send the BPDU. So all the ports will be designated ports. This has received the BPDU from this switch and from this switch also, from both the switches. But it will make only this port as root port because low cost. It is receiving the low cost, so it will become the root port. Right? On this interface, it will now it got the BPDU. It will also send the BPDU to this switch. It is receiving from this switch. It will calculate this my cost is 0 and it is saying the cost will be 5. Right? So this will become the root port. Right? Now everything is done perfect. But in between these switches, in between switch 2 and switch 3, who should be the whose port should be designated port and whose port should be block port? You're getting my point? Yeah. There must be at least one designated port on the link. Now only one port can be the designated port. Then which switch will take the role? This switch will take the role or this switch will take the role? Switch? Switch 3? Yeah. Switch? How? How? Let us see. It will see. He will send the cost as, for suppose think that his cost is 5. He will send the cost 5 in the BPDU. For suppose think that this will be AA for both the 2 and 3. Switch 2, switch 3. Okay. Switch 2 will be inserting the same thing A. Switch 3 also will be inserting the same switch A. Path cost. What it is? Path cost. Right? So what will it do? It is having the cost 10, but it is having the cost 5. Right? You are sending me the cost 10. I am sending you the cost 5. I am the lowest cost. Right? I am the lowest cost. Switch A, this switch is sending 5 and this switch is sending 5 and 10. So ultimately this switch will become this port will become the designated port and this port will become the block. Okay, this is how fast cost is checked for designation port. Right? Designation port is the port on which the BPDUs are sent out. Root port is the port on which the BPDUs are received. Right? It is recording. Once after going home, I'm saying you read it. Okay. So this is the lowest cost. Right? For suppose think that it is also having the same cost 10. Right? Earlier we have about what? Ask me. Yeah, the root bridge and the diameter. Is a road bridge. Is a road bridge. Just he will forward the BPDU. That's it. He forwarded BPDU. His work is finished. He will be assigned. Right? Now it is a responsibility of switch 2 and switch 3 to make elections whose interface should become the designated. Okay, root port is elected because he is receiving the lowest cost from this interface, so he will become the root port, and on this switch he is receiving the lowest cost, so he will become the root port. Okay, but now on this link one port should be DP and one port should be Block port. Then whose interface should be designated port? Whose interface should be block port? They have to calculate it, right? So first what will they check is what I am sending the cost out. He is sending the cost 10. He is sending the cost 10, right? And he is sending the cost 5. Because he is receiving the cost 0 and his cost is 5. Always remember cost is dependent on the type of interface. For suppose think the switch 2 is having fast ethernet, but switch 3 is having gigabit ethernet, right? Gigabit ethernet will always have low cost than fast ethernet because high bandwidth. Okay, so he is sending the 10 and he is sending the 5. First cost will be compared for dp. In order to elect dp, first cost is compared. Cost is compared, right? His cost is 5, his cost is 10. Here he is having the lowest cost, so he'll become the dp. One case is finished, cost is finished. For time being, think that cost has become type. Switch 2 is sending the same cost 10 and switch 3 is also sending the same cost 10. At that time what will be the case? That I want to tell you. Okay. At that time what will happen is now he is sending the cost 10. He is also sending the cost 10. Right? Now sender bridge ID will be checked. Sender bridge ID will be checked. Right? Now sender bridge ID is he. His bridge ID is B. His bridge ID is C. Ultimately B is lower hexadecimal. So he will become the DP. He will become the block. Right? This is the thing. So you came to know what is root ID, what will be the root path cost. Root path cost is the cost in order to go from this switch to the root bridge. That is the root path cost. And bridge ID is sender bridge ID. And port ID is the port on which the BPDU sent out. That will be the port. And I told you the timers also. So this is required to determine and maintain STP topology. You have seen everything, election, everything is happening based on BPDUs. So that is why it is required to determine, maintain STP topology.